Well, hi, and thanks for having me up. Um, it's kind of my Earth Day celebration, Earth Week celebration, so, um. Yeah, like usual in my talks, I have way more stuff in here than I have time for. So please forgive me if I go kind of quickly sometimes, but please let me know if you have a question or something that you really want to hit on and talk about. The thing about architecture is, and design in general, is that it's just, the nature of it is you're bringing a lot of things together. So it's hard to boil it down to really simple explanation, and that's why it's so easy to make these talks so long. Thank you, Jung-Hee, for that introduction. That's very nice. I hope that that's written down somewhere, because that's like the nicest bio I've heard. Did we write that and give it to you, or?
No, I just wrote it up.
Oh, nice. Well, that's great. Thanks. One thing I do want to mention, and I think those of you who are from Madison probably have ideas about this, is that the bottom thing on this little mini bio here is the Oak Park Climate Action Network. So Oak Park's a village of about 60,000, where Frank Lloyd Wright had his home studio when he was working for Sullivan, and then inventing the prairie style and building all those fabulous buildings. And we're relatively, we're a forward-looking village. We call it a progressive place, like Madison is. But we weren't really doing anything concrete about sustainability in the village. So a bunch of us got together and formed this climate action network, and basically said to the village board, you've got to make a plan. And so they got around to taking the sustainability fund, hiring a sustainability manager, doing a greenhouse gas inventory, so we knew what we were emitting as a village, and then we could make a plan. And then that led to the next year, drafting and then passing an electrification ordinance. So no new building can be built in Oak Park with gas, with fossil fuel infrastructure. So that was like a huge thing. It's the first thing in the Midwest. And at least I believe so. I think Ann Arbor is kind of going this way, and is Madison as well. I mean, there must be talk of this afoot. And of course, it really makes the gas industry mad. They come and say threatening things, and if you're a big enough place like Berkeley, they create lawsuits. So anyway, we haven't had lawsuits yet, but a lot of the projects that I've been doing have been kind of proof of concept projects. Is that the right button? Well, I think maybe I need to. Oh, I need to click on the slide and then going. All right. So yeah, I graduated grad school in '91, started working at different architecture firms, but I've always wanted to focus on sustainability, and I'll tell you why in a second. But when I set up my firm in 2006, it was really my chance to just pursue it wholeheartedly and figure out what that meant. I mean, we weren't even calling it sustainability then, we're calling it green. The year 2006 that I set up my firm was the year Al Gore made the movie Inconvenient Truth. So it was starting to get on people's minds, and I just wanted to figure out what to do. So over the years, we've done a bunch of buildings that have been these kind of proof of concept projects. How do you make a zero energy building, or a Phius certified? Phius is Passive House Institute US. A super energy conservation building in our cold climate in Chicago, and of course Madison's even a little more challenging. So what I was able to do in my office, of we've gone between 2 and 8 people, usually hanging around 5 or 6, is figure it out and then go out and talk about it. So the reason that the AIA advanced me to fellowship was because I sort of made the case that not only do I love to figure out how to do this stuff, but I also love to go out and talk about it. So, and tell people also, not just, hey, we did this, but also these are the problems we had. There's a lot of these lessons learned talks about, the stuff you don't want to do. So, anyway, backstory, 1979, I was a sophomore in high school, I think. And I was taking these drafting classes, and it was like the first class that I really felt comfortable in. My brother was a super science genius, and my dad's a research biochemist. So, but that wasn't my route. My mom's an art teacher, and so that's where I came in. So when I was thinking about architecture and taking an architecture class in high school, I thought, I'll go see what books they have in architecture. I mean, to me, libraries and books were always the first thing to do after I had an idea about something I was interested in. So there was that book, A Testament by Frank Lloyd Wright, on the shelf in my high school library. And it just blew me away. The beauty of what I was seeing, because I was a kid who spent all his time outdoors. I did sleep indoors. You know, the idea of connection to nature as an experience was huge. And I could see that in Wright's buildings. I could see that his buildings, as I describe it now, they're in love with their site. They're in love with nature in the way that they create indoor outdoor experiences, in the way they use materials, in the way people experience them very physically, sometimes too physically. So that got me going. I was like, okay, architecture, this is what I want to do. Then I went down to the local bookstore, and it was 1979, so we had an oil crisis going. Carter was in the White House saying, maybe we should use less energy. And, you know, making the oil industry people kind of really angry because they had, anyway. So what was on the shelf was like the first edition of Ed Mesria's Passive Solar Energy book. Now, if you are following the sustainability world in architecture, Ed Mesria, years later in the 2000s, founded Architecture 2030, which is saying we have to figure out how to make buildings part of the climate solution, not climate problem. But there it was in 79, like, here's a handbook for how to make buildings that don't take a lot of energy. And so to me, that was it. It was like the beauty of nature and Wright and aesthetically designing a building to be part of this harmonious world that we call, you know, nature. And then an actual handbook of things you can do, how to face your glass, what kind of glass to use, what kind of insulation to use, how to put your building, you know, in its site, etc. So to me, that was like that has stayed with me ever since. And I think it's because that's just kind of who I am, how I'm wired, whatever. Along the way, I got into these very technical aspects of architecture. And about 6 years ago, I just was, the itch to go out and paint was I couldn't resist it anymore, painting landscapes. So just have a pointer to get there. So this morning I was out at Picnic Point. I just did that painting this morning. So I love to get out in nature again, and just, it's this total mindfulness experience. You're just there, fully immersed in the sense of being in that surroundings and figuring out how to make something of that. Would you all prefer to have the lights off?
Yeah.
Or just do? Okay. The artist, she says isn't really speaking. Thanks. Yeah, great.
Yeah, really good.
And how do I get rid of this thing up top? Do I? Can I just click on this and it will go away?
I don't know if it will.
It won't. Okay, fine. So anyway, I'm going to put some questions. You know, my hope here this morning is to try to give you some things to think about as students, as people engaged in design. And you know, some of these questions I still ask myself, some I can't answer. But I guess the first one is, you know, about sustainability. What is it, and how do you develop a personal approach? And should you develop a personal approach? I mean, or should you just take a definition from somebody else and go with it? I would obviously don't think so. So here's some of my thoughts on it. I'm going to do some kind of the philosophy and theory here at the beginning, and then get into some more specifics at the end, but heavy on the ideas. The first temperature warning, that's not actually part of my slide, but it's actually a really perfect statement. God, I'm glad we're getting this on screen. That's from the projector. So you know, the 3.9 billion years of this globe sustaining life, and it's interesting to me just that the symbol of harmony is a circle or a sphere. It's going to be okay. There's been a lot of cataclysmic events, and we're currently a cataclysmic event in the making, slow motion train wreck. But it's gonna be there. The beauty to me, the miracle of life is that it finds its way to continuation, to there's a nice word I'm looking for. Anyway, keeping going, right? Which is not licensed to go and just do whatever, because it'll be okay. It's an imperative to figure out how we do what we do to make ourselves in harmony with that idea. And the problem is that what we've been doing, what we've been doing for the last 100 or so years is not that. So I did a little TEDx talk years ago, and I was talking about trying to get into biophilic design, and very early exploration for me. I shouldn't have done a TEDx talk on it. I didn't have an experience with it, but it was like a chance for me to study and think about it. And you know, the idea that if you think of the human story as a 24-hour clock, okay, so starting to become hominids about 1 million years ago, and think about where we are today, the stuff that we take for granted, this civilization and our expanse over the earth. If you had a 24-hour clock, that's the last like 7 seconds of that clock, you know. But so for the first 23 hours and 59 minutes and 53 seconds, we were living outdoors in shelter that we would determine in environments that we would select for ourselves, and what we were getting in terms of our sensory and physical experience was a world apart from what we're getting now. And I'm not just talking about the toxins and stuff that like, I'm talking about the actual feel of grass underneath your feet and the sound of the wind in the trees, et cetera. So, so my kind of humorous comparison here is like, what is it like to go get a drink of water? Well, 20,000 years ago, it might have been like that on the left. And today it might be, I'm gonna hop in the car and drive down Cicero to the 7-Eleven to get a plastic bottle of water. Is there a difference in experience? I would say, yeah. I would rather be on the left than the right, right? So what is that doing to our minds? What is that doing to our bodies? And what do our genes expect out of the environment? That to me, like my dad was a biologist, so I'm always thinking about this in terms of science. You know, your mind, your experience is craving this kind of thing. And what are we giving it? How do we do that, right? So I'm a real Tolkien nerd. I love J.R.R. Tolkien. Lord of the Rings was like practically my Bible as a teenager. And so when you read about that, you know, the orcs and Mordor and all the horribleness, Tolkien actually based a lot of that on his experience being in World War I in the trenches. But it's kind of, you know, when you look at the model of what we've been doing in the industrial time, we have extracted toxic fossil fuels to create a lot of energy to put into wasteful buildings that spew out exhaust, and that exhaust and everything else that we consume is mostly waste. So we think that we can throw it away. Well, of course, away is this really big patch in the ocean that's got giant amounts of garbage, right? So there is no away. When you start seeing, you know, PFAS in your water in the lake that you're swimming in, we used to think that was away. Well, you know, there is no away. We're in an ecological closed system here. So that's what orcs do. And we can't do that anymore, right? We have to do what elves would do, and harvest our energy from sunlight and wind, put it into efficient buildings that therefore have surplus and can share that with their neighbors and up to the grid. And then the things that we use become compost. They don't become garbage. You walk into a forest and the trees that are lying down are not garbage. They're the next generation of the trees, right? So that's the model, right? And so when you really start to do the what if, you got to just let yourself go. You gotta go there in your mind and see. So I did that on a large scale here. This is a map of Chicago. You recognize it? I said, what if the zoning code said you couldn't build anything within a mile of any major waterway? So the Chicago River, the Des Plaines River, Lake Michigan, because they're precious. And if we build close, we'll be putting nasty stuff into it inevitably. So I just started drawing over the USGS maps. You know, you can get the maps that looking up to scale, so you can do it. So it was really fun to start thinking about it. And I'm not really expecting Mayor Johnson to say, well, let's do it. This would be more disruptive than what Hausman did in Paris for Napoleon. But anyway, it's like, yeah, this is where I want to be. And when you start looking at like, what are some of the decisions you make on a project? So at a much smaller scale than this, but after I did it a while, I was like, okay, so if we have these things and we separate them, the other zoning code thing was that no citizen could be with longer than like a 7-minute walk to open space. Right? So that's what I want to be able to get out and not hear the freaking traffic and be able to see the stars and the moon like when I was growing up, and now I can't. I gotta go to North Michigan for that, which I'd love to do. I mean, it's a good excuse, but anyway, so yeah, I was like, all right, so then therefore cars wouldn't make sense here. You wouldn't cars in a place like this. You would have, rail lines or something, and the rail lines would be elevated so that animals would go underneath there and they wouldn't be hurt. And a deer could go from the lake to to wherever, the Mississippi. So anyway, this is a lot of fun. So I guess what I'm saying is keep the what if going. So and tell me what should I name to wrap up here? 10 months. Noon?
I feel like 10:45, 10:42.
Okay, geez, okay. Here we go. So yeah, so basically where I've come to is this will continue to evolve, but basically 3 main components to my thoughts about what it is to pursue sustainability in design. The first one is site-specific conservation. So every building, when I say that it is like an evolved building, it's like, what if it were a creature that evolved in that site to take advantage of the local sunlight, water, the characteristics of the soil. So it can be low energy by nature of just its fittingness to its environment. So that's the essence of passive design. You make something that doesn't take a lot of inputs to keep going. So that's number one. And then the other 2 relate to materials and aesthetics. So the first one means, okay, we don't need a lot of energy to operate this building because we designed it smartly. The next part, though, is that the energy that we use, the materials that we use to build with, can take a huge amount of energy or a little bit of amount of energy, or they can actually sequester carbon by virtue of being plant-based. So that is a really important thing that's kind of come up in the last 5 years, and it's something we've been focusing a lot. We'll talk about some specific numbers later on. So that's like the materials we build with. And fortunately, a lot of plant-based building or materials are also usually not toxic, so that's a big thing. And then the third one is designing for physical and psychological well-being, which is, to me, the essence of biophilic design. We want to design places that make us feel good and make us interact well with each other, and so that's like physical health and really the psychology of place. So when I talk about passive building, really my main training in this came from the Passive House Institute US, Phius, which I'll just call it Phius. And that is as I see it, just a better way of building than what I learned coming up through school and through practice. If you go just to the building code and you look at sort of standard practice, it's pretty low quality standards in architecture in the US these days. So what Phius says is basically you have to craft that thermal envelope, and you have to model it with an energy model so that you're going to achieve certain metrics. Basically, it draws a line in the sand and says in this climate, a building should be able to hit these metrics if it's designable. And so what that means for cold climates is that you have good orientation shading. So you're not going to put a huge bank of windows on the north and nothing on the south, unless you absolutely have to, like our Austin Gardens building. But generally, to make it easy on yourself, you put the windows in the right place. You make them the right solar heat gain coefficient. You put a decent amount of shading on it, and all that stuff can be modeled in the energy model. so you're aware of the implication of your design decisions. And then like this little red line that you see running around, everything here, that's the air barrier, continuous air barriers. That's a detailing challenge that I never had to even, I never was asked to think about in all of my years coming up until I took Phius training and started doing it. And you start to realize certain transitions, like here at this overhang, you know, took some real study. Window details always take a lot of study. Wall to foundation takes a lot of study. So by now we've developed this catalog detail depending on what materials we're using and what kind of arrangements we have. So air barrier, and then the insulation has got to be a jacket. It has to be like, you know, you wouldn't wear a coat that just has big open seams, but that's the way we typically build buildings today still, and especially houses. So yeah, it's elevating the thermal envelope design to a point where it takes a shockingly low amount of energy. The first one we did, first pass offs we did based on where the code was at the time, used 90% less energy to heat and cool than if we had built it. I mean, and the thing is, you don't see that when you walk in. You can't perceive it because it's the quality of the construction, but it's stunning how good you can do. So this is, yeah, our right size passive house, as we call it, in Oak Park. Small, about 1,800 square foot house. But you can see here the plywood has been painted with a fluid applied air barrier, so that's something you can't see once it's covered up. We get this continuous jacket of polyiso cyanurate insulation, about 4 inches of that, gives this thermal break to the outside. You know, good shading here on the west and on the south. And then, yeah, you cover it up though, then you don't see it. And so people, this is the hard stuff. It's like, you know, it could look like a really poorly performing house next door. You wouldn't know unless you go in and test it. So, yeah, so that's passive building. So conservation is the mantra there. And so that got me asking the question, well, how much conservation is enough? I mean, if 4 inch of insulation is good, how much? Well, so how do you determine that, right? So that's where we really get into the energy model. And one of the things that Phius gives us is specific targets that are climate based. So there's like 111 climate zones or something in the US that you can download and design to. This is an example from a retrofit project. So retrofit, we had an old house we were going to remodel. We wanted to see what the impact would be of our insulation strategies. So we have a number of these iterations going. But if you look at the before on the right, on the left, you can see, you know, this is like telling you, well, the walls are poorly insulated and they're consuming like 80,000 kilobtu's per year to heat that building based on that. And so with our insulation strategy, we were down at like 25,000. So we cut that, you know, by a factor of like 75%. That's the beauty of insulation. It's so it's the unsung hero of sustainability movements, you know, glorious cellulose. So yeah, you look at the scale of these things. This is 200,000 kilobtu's per year. This is 75,000. So the post retrofit is all that. So we use these models to figure out what's going to make sense. It's going to tell us how big our mechanical needs to be. And this is the house, actually. We just completed it about a little over a year ago, almost a year and a half. And if you're ever watching America by Design, which is going to be airing on CBS this year, we just did a shoot for this, and so it'll be airing, I think, later in the summer or the fall. But anyway, so yeah, so there's like, these are the metrics that Phius gives us: heating demand, heat and cooling demand, which is the annual amount of energy it takes, and then heating and cooling load, which is the peak load. And so that's what's really important when we think about electrification and changing the grid to electricity, is that we got to make sure the peak loads aren't crazy, or else we'll need bigger power plants or more power. And then the source energy, the site energy, just has to do with the overall energy you're consuming there. So this building, we got to a net positive. So we're making more energy on site with solar panels than we're using over the course of the year. You can do it in a 1902 house in a historic district that still meets the historic preservation guidelines. So I'm gonna gloss over this because time is short here. But basically the idea being just, there's an existing house, it's got all this energy tied up in the materials, so how do we use that? Aside from the fact that it has culture and history tied up in it. So I'm gonna show you very quickly, a little case study. This is my house. This was during construction a couple of years ago. Retrofitting because I had asbestos siding over my lead painted cedar. So many generations of toxicity that I was gonna undo. And so just to show you the power of design for conservation here. Look at the guide here. So this is EUI, energy use intensity. It's a standard we use, which is basically BTUs per square foot per year. We changed this to kilowatt hours per year, just so we could tie it to our solar production. But anyway, this is how we got the house. Like all historic houses that I've run into that haven't been retrofitted, most of the energy, like 75% energy that comes in, is just wasted. It just goes out through the walls and mostly through the roof. So this red bar here is the heating, and you can see that when we moved in, we needed over 100,000 BTU hour furnace to heat and cool that thing. So first thing we do, insulate the roof. And that kicks us down from 113 where we started to 77 on the overall energy. Then do the walls and floors. Look at that, 38. We like cut it by a factor of 5 already. And here's what's one of the other real magics here is furnace size gone from 100,000 down to 26,000. We've gone from 8 tons capacity to 2 tons capacity just by insulating the thing and making it more airtight. And so then we changed the mechanical system. We pulled all the gas infrastructure out, got rid of that toxic gas stove, replaced it with induction, which I love to cook on. Got rid of the gas dryer, which is, if you think about it, a hysterical energy model. So we're gonna burn a toxic flammable gas to make your clothes really hot and damage them. And we're gonna blow that heat out the side of the house. And we're gonna put another hole in your house to do that. Versus a condensation dryer, which we have, which is a heat pump condensation dryer, just make a little bit of energy, get the moisture to condense out, it goes into the plumbing line, and it uses like 1/10 of the energy and no fossil fuels. So this is like the shifting that's going on across the board with our technology. So yeah, we changed to heat pumps, and then we added solar, and this is the original solar, which is 12 panels. We added another 12, and that's how we got to net zero energy house. But the first cold snap, my wife got out of bed and said, "Whoa, the floors, this stuff works." And the really great thing, and there it is. You can see the Chicago skyline in the distance, a little bungalow with its solar panels, and the wonderful rain garden in the front yard. All my roof drainage comes down to the front. So yeah, so that's kind of how we do it. This is a Frank Lloyd Wright house we're doing a similar thing on. It's the Bulge House in North Park. Owner said, "We want to get to zero energy with this." I'm like, "Oh God, how are we going to do that? Without affecting the historic integrity of this house?" So we can talk about that later if we have time. But anyway, the fact that the roof is flat, you can't see the solar panels from the street. So that was the key aspect of it. And we put as many back on the non-historic garage as we could. Okay, so I'm going to zoom over this one too. Basically, the idea is that we have to retrofit our buildings, and we have our greatest opportunity for sustainability in energy is in retrofitting buildings. But how do we do it at scale? Especially to maintain equity. What about people who can barely afford their mortgage, let alone their utility bills, right? This is difficult. What about renters? How are you gonna get landlords to change their building? Yeah. So a quick word on embodied carbon. Let's look at the time here. Yeah. So that was all kind of the conservation, the first leg of the stool. The second leg being the amount of energy is tied up in the materials of the building. So since a couple years ago, we started figuring out we have to get serious about this. And just like the energy modeling, we've got to model this. We got to model the materials we use. And so there's a tool called Beam. The Beam tool, yeah, by Builders for Climate Action out of Canada. And this is basically a free thing. It's a Google spreadsheet that you can download. And it's pretty easy to use. And it basically gives you what they call cradle to gate emissions. So how much energy does it take to extract the material, to manufacture it and get it ready to ship? So this doesn't have shipping energy in it. It doesn't have what happens at the end of the life cycle when the building's not used anymore. Those are important considerations, but this is just basically cradle to gate. And when you do this on your building, then once again, just like the energy model makes you conscious of your design decisions, as far as operational energy goes, this does it in terms of the embodied energy. And so like this building here, we did, we had some really clever strategies to get rid of the floor slab, the concrete slab, and replace it with basically a wood structure. But we couldn't do that in the garage, so Sarah was looking at this yesterday going, why is the garage such a emitter? It's like, well, it's all this concrete, and then there's windows, which there's nothing we can do. We need glass. So glass is energy intensive. But if you look at the exterior walls, they're negative. And so this is where we have to go. If we use cellulose, if we use wood fiber insulation, if we use straw is the king of low carbon, we could start storing more energy in our buildings, or more carbon, I should say. And the reason that is that when straw as a plant grows, it uptakes carbon, right? It uses it and it takes it out of the environment in the form of carbon dioxide, right? So at the end of its life, if you just leave it to rot or you burn it, all that carbon goes back into the environment. But if you turn it into a building material, you put it into your wall, it's just going to lock that carbon up, and so it's basically storing. So that's a building strategy. Just like with regenerative agriculture, their idea is we make the soil more healthy, the microbes will suck up all this carbon, and it's this huge carbon sink. So that's why you got to get away from herbicides, which kill the microorganisms, kill the soil, and just get us into this big emission situation. So our goal is to try to get our buildings here into the green where they're actually storing more energy than they're using. We haven't gotten there yet. I'm gonna just race over this. I was at Greenville in the fall to talk about our study of this, for this one particular building we modeled. This is a new house we were building in Glenview, suburb of Chicago. And we looked at these three different recipes for the building. Our original one, which we had used on our first Phius projects. And so, this, if you look at this number, is the standard sort of 15 kilograms of CO2 equivalent per square foot. So that's the standard you use when you're figuring embodied energy. What is the kilogram CO2 equivalent? So this is all the emissions that happen with the materials we're using. So in this case, we had a EPS styrofoam, basically insulation on the outside. It uses a blowing agent, and it's a petrochemical product, and so it has some emissions involved with it. And so that's why we're up here at 15 kilograms, and it has a concrete slab. And so we got better with this, and we said, let's get rid of that foam plastic and just do all cellulose. We had to get a little more clever with our vapor membrane, figure out how to keep water vapor out of the wall. They were down below 10. We've replaced the concrete slab with a concrete less slab. So a couple layers of plywood on top of the EPS. And then we said, all right, how good can we possibly do with all the materials that we can get today? And then we're down here at like 3. So it's like using straw for the walls and the roof, and then substituting what's called foam glass instead of plastic insulation underneath the slab. So anyway, even at this, the best that we can do, we're still not storing, but we're low on the low side. That's good. But look at the walls and the roof. They're the storing. So actually, if we make them thicker and you use more insulation, it would cost more, but you'd actually be storing more. So that'd be one way to get to it. But I feel a little bit like that's being consistent. But unfortunately, this is how builders usually build. Often build spray foam, with the HFC blowing agent and code minimum. So this building consumes about 60–70% more energy than the ones we're designing if you're just building to code.
And if you look at this, intensity here, you're at 30 kilograms CO2 equivalent, so a total net emissions of 87,000 kilograms CO2 on this building versus, our best, which is under 10. So these decisions really matter. They matter in interiors. They matter, across the board in your selection. So this was a 30-year life cycle emission study of that. You could use a little more energy to get net positive. So this building is that Oak Park one that I showed you, the historic house with all the solar on it. So it took more energy to get it that much more efficient because we had to use foam. But it over 30 years is the winner. However, if we build a new house out of all straw, it would be like 11 years before that energy spend on the new house to get us there. So this is just one of those head scratchers that makes you think about, okay, what's the right thing to do here? You just model it, think about it, talk about it with your client, figure out what approach you want to use. Okay, wrapping this up with the third leg of the stool, which is biofuel. So how do environments affect us, our bodies, our minds? We're used to living in rooms like this and in cities and, walking on asphalt with shoes that are very cushioned. I've been wearing minimal shoes for 15 years, so, I'm trying to get there, but, anyway, yeah, I really believe that we're meant to be, in touch with that. So how do we put it into our buildings? How do we make a building that's as radical a departure from what we're used to as that Chicago map that I showed you is from the way Chicago is right now? And it's so much easier to do on a building because you don't have all the entrenched interests and all the history and all the stuff that's there. You can do it. And if you're renovating a building, you can do it as well. So when we did this park district competition, we were looking at biofuel design and reading the different literature and trying to figure out a simpler kind of key points that we want to hit to make sure that we're doing the good thing for people, right? And so there's a lot of literature out there and like 14 patterns of biophilia from the paraffin that you're probably familiar with. But I boiled it down to 5. That I really felt if I had these as an architect, I think that the building would be really well grounded in environmental design. So the first one is prospect and refuge. And so that's that idea that you can create a space where you feel safe and yet free. You feel like you can that it's got a dynamic of kind of lower embracing spaces against more expansive light-filled ones. There's sensing nature, so in terms of materials, visual patterns, smells, sound, movement of water, etc. That needs to be in the space. Dynamic light, so that's there are a lot of rooms and buildings we're in that are pretty much uniform, and so it doesn't give you any sense of hierarchy, any sense of movement. And if you go for a walk in the woods, it's so dynamic. I mean, the color changes, the illumination level changes. So yeah, so kind of creating those metaphorical spaces that you're thinking about that are inspiring you can be a way to lead into the manner in which you want to create, let's say, and then complex order. This is one that Grant Hildebrand talked about in his book, The Right Space. It's a great book. Yeah, I know some people have to go. Thanks for coming. And it's the idea that in any work of art, you can see the order, and yet it's complex enough. It's ordered without being worn. And so piece of music, being a sculpture, building, it needs to have enough order that we feel oriented, we feel like it makes sense. And then this is, I think, what I was responding to when I was looking at Frank Lloyd Wright back in the day. There's an order there, and it's based on the actual site and the experience, and those two things come together. And that's just so exciting. And then finally, enticement and discovery is kind of the way I'm putting something that Milligan talks about, which is that when you see a building or you're moving through a building, it can be a space or a series of spaces. There's a place you want to get to. There's the moment in that building that's really important. So to use Frank Lovetti's example, that would be the heart in the living space, right? And so that's signaled on the exterior with the sculptural object, the chimney coming up and out, sort of anchoring all the horizontals. And yet you have to figure out how to get there. And that's kind of the excitement of this building, is that that you then go on a path of discovery that builds up your anticipation, and it actually creates it hits the dopamine or some whatever in your brain. It actually stimulates you in this way. And like one of the greatest examples is his famous House Falling Wonder in Pennsylvania, which if you haven't been, you gotta go. But what happens there is you cross a bridge first. And the bridge is like a dangerous place, when you're above water, it's potentially fatal, right? And he's put the building above the waterfall, which is just this sort of defiance. It's like, if you look at sort of the idea of yin and yang, this dynamic, dynamic balance, it's right there in architecture. To put stability and repose above total dynamic action. It's aesthetically brilliant. But anyway, so you get this thing where you cross the bridge and then you come along the backside of the house. You have to go through the stone, and then you're in the space by the hearth with this view. And it's thrilling. It's thrilling. So anyway, we can do this with you. We can do this in buildings and in spaces individually, So it's a matter of figuring out how you want to orchestrate it, and then taking that program and moving things around in such a way that you create an experience. So, so in this building here, the classroom space, which is the tall lit space, was clearly the ultimate place that you wanted to end up. But first, this little snout comes out here, and that's beckoning you with wood, and at night it's the dynamic light is showing up here. But then come back to the plan. But then when you come through that entry into this lobby space, this is really kind of the main sort of experience that I knew everybody was going to be able to have. And this is where we can get water, rock, light, wood, all these things coming together. And when you look at the floor plan, we took all the roof rainwater and directed it down to be able to spill over here into this this on the lower right here. You see that's a big rain garden. So it's a chance to have native plants to create a really beautiful environment. This is going to attract birds and butterflies, all kinds of pollinator species, and that you see that when you walk in. And so we got into this kind of more organic shape as a way of, first of all, breaking the tyranny of the rectilinear, which is usually what we have to deal with on sort of narrow lots, which is mostly what's designed. But here we wanted to fit it in among trees and among existing playgrounds, and it was really nice to just let this thing kind of flow in such a way that didn't. So so anyway, this is the main space, there's the classroom space. And then on a smaller scale, this house, for instance, we got the entry here with the two-story expression, which is kind of hinting at a two-story space beyond, which is the living space. And at the edge of that living space is this kind of this lower ceiling here. And so if you're looking at this lowered ceiling with couches and there's a wood stove back there, that's kind of your little shelter. So it doesn't look anything like Franco Wright, but this idea of the dynamic tall space that looks up and out to the woods and the tree canopy, which is part of what they loved about this site. It creates that dynamism. So that was the thought as I was designing this floor plan, that you come in, there's this enticement that you can kind of see through, but then you need to kind of come around the corner really get that experience, and it opens up for you. Meanwhile, the kitchen, becomes this sort of almost cave-like experience of wood and stone, that's adjacent to that big space. But yeah, so creating this dynamism. Yeah, I think that's all I've got. These are a little more technical resources, but I'd be happy to share any of this stuff with people if they have questions or, the one thing I do want to point out here is if you're interested in biophilic design and in regenerative buildings, just like I was talking about regenerative agriculture, check out the Living Future Institute. They created the Living Building Challenge and the Biophilic Design Initiative. So there are a lot of great resources there, and a lot of inspiration. The Living Building Challenge is basically what if a building was like a flower. It's some energy, it creates habitat, it creates food, it doesn't harm anything. It's not about doing less harm, it's about making something that's actually really good. So, so yeah, that would be the one I would really direct everybody to, but there's a bunch of good stuff here. So thank you. I'd love to take any questions. Yes, sir.
I want to ask about your asset building model and how it relates to new sustainability technology. Because in Europe, I think in Alaska, there are like experts for heat pumps. You mentioned heat pumps for like walking machine, but does your building model kind of design to accommodate those new technologies, or is it more of like bypassing it to more kind of a holistic system of sustainable, and make those new technologies can fit and maybe even
Yeah,
become cheaper?
it's, are you in the class this afternoon with Neith?
No.
Okay,
No, I'm not.
okay, well, because we're gonna talk about that in detail. But yes, the energy model that I'm using is called, now it's called METR, METR. It used to be called Wookie Passive. It's out of the Bassett-Dilley Institute, and it is extremely granular. So whether you're using an air source heat pump or a ground source heat pump, a condensing dryer or electric resistance dryer, all those things are in the program. So, and you can see individually the energy use of each of those. And it looks, let's see if I can, actually share it a little. Yeah, here's what that energy model interface looks like. And so, as you're looking at the, all the elements here, let's see, systems, so mechanical system, let's see, heat pump, here's the, the data input for the heat pump, and, and basically giving you the data month to month. And so, yeah, I mean, it's very granular. Does that answer your question?
Yeah.
Yeah. And yeah, I would say generally that, the interesting thing in the balance of this, so this is actually the before model for my house, by the double red, actually, not still green checks. But because we wanted to get the baseline and understand how much we were saving. Yeah, what you're looking at is the balance between how much is this building going to take and then how much energy we can give it to keep it at set. And so so when you get a more efficient building, internal loads really matter. Like if you're using resistance heat, if you're using like incandescent bulbs versus LEDs, the incandescent bulbs are like little heaters, So so anyway, yeah, it's all part of the balance. Yeah. Yes, in the back.
The other big component of impact and size of buildings, what's requiring, because if every household around the world had the average US household size, we'd be doomed like in 2 years. What is the matter of inputs that you have in your design on encouraging people to think smaller or make use spaces and things to kind of avoid the McMansion and use of spaces.
Yeah, that's a good question. I would say that in general, good design makes use of space in a smart way. And, you know, a lot of the houses we've done are, you know, under 2,000 square feet per family. And yet, sometimes with, especially during COVID, and saw things expand, because now we have to have an office and, you know, all these things at home. And in order to have acoustic separation and whatnot, you know, it's just, they were getting more bigger. So I think that there's two sides to that. If you're building with energy intensive materials, then it's a double win. It's a problem. You've got all consumption of space and the consumption of material and the energy you need to heat, cool that space. So yeah. However, if you get to really, you know, carbon storing materials that you're building with, then it's less of an impact. But yeah, generally, I would say that the mindset of most people who are coming to us looking for efficient buildings, and are interested in sustainability are already on board with making work. Nonetheless, I try to do this for myself. I was like, I'm gonna design a house that's only what I need, as small as I can make it. And then pretty soon I'm talking to my wife and she goes, no, one bathroom, you gotta have another toilet, you know, like, you know. So it's like, what do you really need? You don't actually, you know, need a toilet at the house. You could have that. So need versus want, it's all there. And yeah, I think I'm hoping that we can keep turning that average home size down, because it's crazy how big things got. And for so many useless spaces, I mean, Sarah Susanko's book, The Not So Big House, is a great one that really helped people rethink that and make places that feel better. Sorry, I'm gonna wrap up.
Yeah,